Hello, today we are doing chapter 7, section 7, and it's going to be more fun with factoring. Today we're going to recognize and factor special products. You might remember this when we multiplied these special products out. We're just going to be doing kind of the opposite. Difference of two squares, by far the easiest factoring there is. What you do is you look to see if that first term is a perfect square. Do you have a minus sign? Is your second term a perfect square? If so, it's just going to be a plus b, a minus b. Take the square root of the first term, put a plus or minus, take the square root of the second term. So if we look at this first one, x squared, that's a perfect square, x times x. 25, that's a perfect square, 5 times 5. So I'm going to think of that as x squared minus 5 squared. And a lot of times I won't even write that down. I'll just think about it in my head that way. So then x plus 5, x minus 5. And that's all there is to it. On example number B, 4z squared. That's also a perfect square because that's going to be 2z times 2z. 1 is a perfect square, 1 times 1. So I'm going to think of that as 2z squared, or 2z quantity squared, minus 1 squared. And when I do that, I get 2z plus 1, 2z minus 1. All right, sometimes we get to do some fun things. On this one, we're going to use special product pattern to evaluate 54 squared minus 48 squared. So that's a perfect square. That's a perfect square. You can write that in factored form. 48 or 54 plus 48, 54 minus 48. So that's 102 times 6, which is 612. And again, people that are really fast at math have really got some of these, they're not really tricks, but understanding of patterns down. So that's one that you probably could have done without a calculator. So let's just take a second. I'm just going to ask you to stop and do the first 4 on your own. Hit pause and then check yourself. Yep. 36, the square root is positive 6, negative 6. Think of that as 10 squared. So 10 plus m, 10 minus m. And the order does matter. You can't have m minus 10. 9n squared, think of that as 3n quantity squared minus 4 squared. So 3n plus 4, 3n minus 4. 4h plus 7, 4h minus 7. All right, let's do ones that start to get a little bit, I'm not even going to say more difficult, just different. These are what we refer to as our perfect square trinomials. And when we start solving things a little bit harder, having a perfect square trinomial can make your life a lot easier. And knowing how to create a perfect square trinomial can make your life a lot easier. When I say perfect square, that's what it is. It's 2 factors multiplied times themselves. So a plus b times a plus b. And what you notice is your first term and your last term are going to be perfect squares. And if you were to multiply those and double them, you get your middle term. So you kind of have to think in a roundabout way on that one. So on this one, if I were doing this, I would start by thinking, well, that's a perfect square and that's a perfect square. So n plus 4. And if I multiplied those two together and doubled it, yep, I'm getting 8n. Oops, I almost forgot my square right there. So here, 4x squared, that's a perfect square. 9, that's a perfect square. So 2x, and it's going to be a minus sign. I'm going to double check that middle term. 2x times 3 is negative 6. Double it and I get negative 12. All right, this one, we're going to solve x squared plus 2/3 x plus 1/9. Don't let the fractions intimidate you. You're better than a fraction. There's a way to get rid of those fractions. You look at your common denominator, it would be 9. So I'm going to multiply each term by 9. And then if you're a little iffy on your fractions, 2/3 times 9, you can cross cancel, and you're going to be left with 6. 1/9 times 9 gives me 1. Well, that does look a lot easier. And when I factor that, it's going to be a perfect square trinomial. 3x plus 1, quantity squared. And we're solving that, so you take that factor, you set it equal to 0. Subtract 1, divide by 3, you get x equals negative 1/3. All right, hit the pause button. Try these 6 on your own. I will give you a hint on number 13. I would probably try and multiply each factor by 36. On 9 through 11, you're just factoring. There's no equal sign, so you can't solve. On 12 through 14, that's where you're going to use your zero property and actually solve. All right, good luck. M minus 1, quantity squared. D minus 5, quantity squared. 3's up. I almost didn't factor out my greatest common factor, which would be a 9. When I do that, I'm left with z squared plus 4z plus 4. Not having the greatest handwriting day. I'm sorry about that. So that's going to be z plus 2, quantity squared. Now on 12, I need to factor that first and then set it equal to 0. When I factor it, I get a plus 3, quantity squared. Set that equal to 0, and I get a equals negative 3. 13 is 7 over 6. 14, as soon as I see two terms, I should think difference of two squares. So n plus 9, n minus 9. So you get positive and negative 9 as your answer. All right, let's do a word problem. A bird picks up a golf ball and drops it while flying. The function represents the height y in feet of the golf ball t seconds after it is dropped. The ball hits the top of a 32-foot tall pine tree. After how many seconds does the ball hit? I think they're kind of leaving a few things out here. Did they give us a function? There's our function right there. 81 minus 6t squared. So I think they kind of missed something on that one. So here's our function. We're going to go ahead, subtract 32 from both sides. And 32 is the height of the tree. It's a difference of two squares, so we can factor it. And you're going to get 7 plus 4t, 7 minus 4t. However, one of those doesn't make sense because you can't have negative time. And you're going to get 7 over 4, or 1.75 seconds. And again, that one I think was a little bit confusing because you're not really given the function right there, but we got it. Well, I am going to go ahead and stop there, and hope you enjoyed.